Hello, thank you for watching this short presentation. I just wanted to give a quick introduction of myself. My name is Scott Lee, and just wanted to give a very quick intro of my background and experience as a stress analyst. Today's date is March 2nd, 2025, just for reference purposes. So, in this first slide here, just wanted to give a high level summary of my overall experience as a stress engineer over the past 13, 14 years. I started working at Boeing in 2011, and I've since then moved across various different companies such as UTC Aerospace Systems, Raytheon Missile Systems, Northrop Grumman, Boom Supersonic, L3 Harris Technologies, Virgin Galactic. I've worked at NASA JPL, and my last stint has been at Virgin Galactic. Some of the key projects I've worked on throughout my career was leading the stress team for the 737-800 BCF wing center section at Boeing. I've worked on the 787-8-9 platform at Boeing. I've worked on supporting the Mars sample return program at JPL. I've analyzed various components on the XB-1 prototype, such as the main landing gear and the fuselage components at Boom. I do have MRB stress experience as well as composite manufacturing experience while working at UTC Aerospace Systems and Northrop Grumman. I have a lot of experience with finite element modeling, worked on finite element modeling with strain gauge correlation at L3 Harris, as well as being a lead FEM engineer for multiple programs at various companies such as L3 Harris, Northrop, and Virgin Galactic. My primary skills are finite element modeling uh, using VMAP and Nastran. That's what I've focused on throughout my career. I do have a lot of experience working on structural analysis for both metallic and composite. And I do have some leadership experience training junior engineers in FEM, as well as leading stress teams and leading FEM programs. This next slide here is just showing a distribution of expertise pie chart. As you can see, my primary expertise is in FEMAP and FEM and finite element modeling and a lot of composite structures analysis and composite finite element modeling. And I do have a lot of experience using FEMAP and Nastran. So as you can imagine, I've run all the different solutions, solution 101, 103, 105, and 106. I do have experience with nonlinear modeling. I'm very experienced with building global internal loads models of large aircraft platforms, as well as modeling detailed breakout fine grained models. And as I mentioned before, I have a lot of experience modeling both composite and metallic structures. Some notable achievements in my throughout my career was developing both coarse and fine grained mesh models for the 737-700 to achieve 90% strain gauge correlation to test data. I developed highly complex global and local models for both classified programs as well as while I was at Virgin Galactic. For the Delta spaceship program, I was on the internal loads modeling team. So I did a lot of modeling while working on that program. And as I mentioned before, I have performed highly complicated nonlinear analysis for complex metallic structures to understand post-buckling behavior. In terms of experience throughout the aircraft, here's just a reference figure of the 787 of the different assemblies. And I just wanted to quickly go over my experience working on the different areas of the aircraft. So in terms of the wing, I have worked on the wing center section and the outboard wing structure while working at Boeing and Virgin Galactic. For nacelles, I've worked on nacelles while at UTC. I've worked on some on landing gear components while at Boom and Virgin Galactic. For the fuselage, I've worked on fuselage primary components while at Boeing, Boom, L3 Harris, and Virgin Galactic. And I've experienced working on vertical and horizontal stabilizers, rudders, ailerons while at Virgin Galactic. So as you can see throughout my career, I have experience working on various different structural assemblies throughout the aircraft. In terms of additional contributions to the aerospace industry, I am a guest lecturer at UCLA USC. I get invited every year to give talks. Some of my lectures have been recorded and they are on YouTube, so feel free to take a look at some of these links if you want, or if you're interested in watching some of these lectures. They've primarily focused on composites, analysis and design of flight vehicle structures, as well as finite element modeling. So yeah, that's thank you for watching this presentation. That's just what I want to go over and just give a quick highlight and summary of my experience. So thank you for watching.